Good morning. In this lecture series, we see about a approximate solution to the engineering problem. As the lecture series, we're discussing about the what is the introduction, what are the terminology, what are the methodology we have to using to substitute analyzing the any component by using of finite element analysis. So now we can move for the approximate solution of the engineering problems. So first of all, so what is the main cases of the approximate solution of the polynomial of minimize the residue? So first of all, we know that the exploring the mathematical elongations of the polynomial approximations, that is a residual minimization techniques. So first of all, what we have to say that, so we have to assume the based upon in your engineering problem, we have to analyzing the polynomial function of the respective of problem. For example, if you understand, take a simply supported beam, or it's like a cantilever beam, whatever you can take any types of structural beam. Okay, so first of all, we have to assume the that is a polynomial function for the respective types of beam. Okay, then we want to substituting the that is called as a unknown solution of A1 and A2. Then we want to find out the where is the maximum load is deflection, where is the maximum load, and we want to calculate the deflection of the respective beam. So first of all, as we know that what is a polynomial, so what is the requirement of the polynomial? The polynomial is the art of the replacing complex function, that is a scattering of the data set, which is the simpler and the polynomial that closely matches is the behaving of the fundamental techniques that are transforms a complicated mathematical expression into manageable form. So what is the primary goal of the polynomial? So we want to identifying the polynomial p of x, that is the approximate function of f of x, while list the minimizing the error between them. So first of all, what is the point of primary goals are there? So we want to find out the numerical analysis and the signal processing and the computer graphics and the scientific computing. So the numerical analysis means the solving the differential equations and computing the integrals. So while going for the signal processing, the filtering and the reconstructing signals from the samples. So the computer graphics is rendering the curve and the smoothing surface smoothly. And the scientific computing is the modeling the physical phenomena in effective manner. So firstly, what is that minimizing the residue, the least square approach? So as we know that the residue of the represent the difference of f of x minus p of x at the each sample point, the essential measuring how far our polynomials stray from the target function. The least square method is providing an elegant solution of the minimizing this error. So what is the called as a definition of the objective, and what are the applying the orthogonality principle and solving the linear system. So define the objective. The main focusing is the summation of the square residual across the all the sample points. For example, if you know that the f of x minus p of x the whole square, so that should be equal to the define the objectives. So applying the orthogonal principle is ensuring the unique of the polynomial solutions exit without recurring the iterative search algorithm. So solving linear system is convert the minimizations of the problem into the system, the linear equation that can be solved directly. So what is the minimax the polynomial approximation and minimizing maximum error? While least square minimizing average error is nothing but the minimizing approximation take the different approach. It is a seeking of to the minimizing the maximum error to overcome and the entire interval. So what is the objective of the function is called as a minimum and maximum of f of x minus p of x of modulus. So this is the ensuring the no single point of the disproportionality error, large error, and creating a more uniform approximate across the domain. So then the summary of the take away. So what are the things we have to take? We want to understanding the approximate solutions of the residue. So balancing accuracy and complexity and complementary strategy, practice computations. So what is the balancing accuracy and competency? So while we have to analyzing the polynomial approximation elegantly, the balancing the need for the accuracy against the computational and the complexity by the minimize residue. So complementary strategies, the resquare and the minimax method for offering the different perspective average error versus the maximum error. The each situated the specific applications, and the practical computations is the iterative the algorithms like remains enable the practical computation based approximation making theory actionable. So overall summary of this classes. So the residual minimizing the numerical analysis, we have to classify as a three things. One is the core concept, processing, and minimizing method and the outcome. So when going for the core concepting, we have to classify it to four types. That is the exact solution approximation, polynomial function, unknown coefficient, and residual productions. While going for the process, the substitution into the differential equation, error identification, coefficient determination, domain error reductions, and the minimizing method is least square and collection and weight residual method. So this is the overall some view of the approximate solution as a polynomial. Thank you.